So this question gives us a system of equations: x plus 5y equals 2 and 2x plus 10y equals -7. We want to use substitution to show that the system is inconsistent. We want to use elimination to show that the system is inconsistent, and also show it by graphing both lines on the graphing calculator. So let's do that. So elimination, no, check that, substitution is first. So we have x plus 5y equals 2. And we have 2x plus 10y equals -7. If we're solving with substitution, we want to find the simplest variable to solve for. This x, this y, this x, or that y. You find the singleton, that's this x, that would be the one that makes the most sense. So we'll solve for this x by subtracting 5y from both sides. So that goes away, and I have x equals 2 minus 5y. And that's going to go in parentheses, and then go in for x in the other equation. Now I have 2 times x, which is 2 minus 5y, substituting it in, plus 10y equals -7. 2 times 2 is 4, minus 2 times 5y is 10y, plus 10y equals -7. -10y plus 10y, that goes away, and I just get 4 equals -7. I don't think so. 4 does not equal -7, so there's no solution. And we had 2 lines, we had equations of 2 lines, so we're going to say that this system is inconsistent. So that's how we solve it using substitution, but we can also get a similar result using elimination. If I'm using elimination, I like to write the 2 equations vertically. So we'll say x plus 5y equals 2, and 2x plus 10y equals -7. How do we solve, or how do we eliminate a variable? I think I'm going to eliminate the x's. I have 2x and 1x, make them both 2, and then change one of the signs. That would be the simplest way to do that. So the second equation, we just multiply by 1. So distributing here, what do we get? -2 times x is -2x, plus -2 times 5y is -10y, equals -2 times 2, which is -4. Add that to 1 times 2x is 2x. 1 times 10y is 10y. 1 times -7 is -7. What happens? -2x and 2x is 0, plus -10y and 10y is 0, equals -4 plus -7, -11. 0 equals -11. Again, I don't think it does. No solution. So again, this is what we call is an inconsistent system. And the last thing we want to do is we want to see what this looks like graphically. So I will graph this on the graphing calculator. X plus 5y equals 2 is one of them. And 2x plus 10y is -7 is the other. So we're going to solve for y. That's how the graphing calculator likes to graph. Subtract x, subtract x. So we get 5y equals 2 minus x. Divide 5, divide 5. And I get y is 2 minus x over 5. So on the graphing calculator, we're going to write y1 equals parentheses 2 minus x divided by 5. Over on this side, we're going to solve for y. So we'll subtract 2x from both sides. Subtract 2x, subtract 2x. And then what do we get? That goes away, 10y equals -7 minus 2x. Divide both sides by 10. So we get y equals -7 minus 2x divided by 10. So on the graphing calculator, we will say y2 is parentheses -7 minus 2x divided by 10. Now we believe this is an inconsistent system. So what does that look like? We're going to go to y equals and erase what's there. So we have 2 minus x over 5 was y1, 2 minus x divided by 5. And then the next one is negative 7 minus 2x. Negative 7 minus 2x divided by 10. And I don't know what kind of a window I need. I think I'll start with Zoom standard, and we'll see what that looks like. So that's number 6. So there's y1, 2 minus x over 5. And here comes y2, negative 7 minus 2x over 10. And it's pretty obvious from this Zoom that those things are never going to intersect. Let's take a look at Zoom decimal. That might be better. Again, there's y1, and here comes y2, and the lines are parallel. So looking at the graph, since the lines are parallel, there's no intersection point. And what does that tell us? If there's no intersection point, conclusion, the system is inconsistent.